Howdy, my name is Catherine Guan, and this is my Chem 119 final lab experiment. So for my experiment, I'll be making a lava lamp, and overall this experiment will cover density, polarity and its relationship to solubility, double replacement and decomposition reaction, and limiting reagent. So, as we get started here, if you see the video, I have the oil already pulled in, just because I need to see how much I wanted to use, and I'm pouring in the water, which you'll notice in a little bit is sinking to the bottom below the oil. This is because water is more dense than oil, so it will sink to the bottom. You'll also notice that the water and the food coloring that I'm adding right now did not dissolve in the oil. It is because the water and the food coloring are both polar, so they don't dissolve in the oil, which is non-polar. And you'll see now that the food coloring is sinking because it's more dense than water, and here as the food coloring expands and dissolves in the water, because they're both polar, you'll kind of see it spreading out. And so that for the next part of the reaction, I will be adding baking soda to the reaction, which you notice will sink to the bottom because it's more dense than oil, and it will start reacting with the water. And you'll see on the whiteboard in the background, I have written the reaction of baking soda and water, which is the double replacement action, which forms sodium hydroxide and carbonic acid, which then dissociates into carbon dioxide gas and water. So the bubbling is caused by the carbon dioxide gas rising to the top of the lava lamp because it is the least dense. And once that carbon dioxide gas is released, the color and the bubbles you'll see floating down are the kind of like the water and the food coloring surrounding the gas. So that sinks back down, and as more carbon dioxide reacts, it goes up and down, and that's where you have your lava lamp. And so once the reaction slows down a little bit, you'll notice that the colors stop, the bubbles stop going. It is because the baking soda is limiting reagent, so once all the baking soda is used up, the reaction will stop. Okay, so that concludes my experiment. I hope you enjoyed, and thank you so much for your time.